Alright, welcome back YouTube. We're solving one problem per day from the Blind 75 list of LeetCode questions. Today we have another fairly easy question. This one is 268 called Missing Number, and it asks us this. Given an array nums containing n distinct numbers in the range 0 to n, return the only number in the range that is missing from the array. And let's take a look at our examples. Example 1 shows us an array with 3, 0 and 1, and of course the only missing number from 0 to the largest number, which is 3, is 2. And then example 2 gives us an array with 0 and 1, and of course again we're missing 2. And then the final example, example 3, we've got an array with 9, 6, 4, 2, 3, 5, 7, 0, 1, and the only thing missing from 0 all the way up to the largest number, which is 9, is the number 8. So that's what we'll have to return. Let's scroll right down to the follow-up. So they say, could you implement a solution using only 0 of 1 extra space complexity and 0 of n runtime complexity? So that means we don't really want to add any kind of data structures to solve this, and we just want to loop through each node only once. So let's go ahead and look at what that might look like if we were allowed to use extra data structures. So we might have a set of integers, and we'll call it values, and we're going to use the hash set implementation, and we just want to loop through our entire array and add each number as we come across it. So we'll just do values.add, and we'll add nums at I. So now we have a hash set that contains every single number at every index in the array. Next, we just want to loop from 0 to the length of the array plus 1, because we're expecting that one digit will be missing from numbers and we'll want to see what that one is. So we'll just do int I again equals 0, while I is less than nums.length plus 1, and increment I. And we'll just check to see if values does not contain I, we can return I. And if we've looped all the way through and we haven't found any missing numbers, we'll just return -1. But we shouldn't expect to hit this case. Let's go ahead and submit it just to show that it works. Alright, so we're visiting every single node twice, which means that the algorithm's runtime is actually big O of 2n, and we drop the constant, so it's still a big O of n algorithm. However, we are using an extra data structure, and that would also be big O of n, and we were asked to keep it to big O of 1. So let's go ahead and delete this code, and let's see how we can accomplish this algorithm without any extra space. Well, after doing some research, I actually found that there's a method that already exists that you can use to determine what the total would be for adding all numbers up from 0 to n, and what we can do is use that to determine what we should have, and then just subtract what we actually have. This method is called Gauss's rule, and all it is n times by n negative 1 divided by 2. So let's go ahead and write an implementation using Gauss's rule. First of all, we're just going to compute the actual total that we have. We're going to first set that to 0. Then we'll just iterate through our array and add up every single number at every index. So we'll do int I equals 0, while I is less than nums.length, and we'll increment I on each pass. And we'll just write actual total plus equal to nums at I. So now our actual total will equal the sum of every number at every index. Now all we want to do is work out our expected total. So what we'll do is we'll just set int n will equal nums.length plus 1, because we're expecting that one extra digit. And we'll just write the expected total equal to Gauss's law, which is equal to n times by n negative 1 divided by 2. And then the last step is just to return the expected total negative the actual total. And that should give us our missing number. Let's go ahead and submit that just to show that it actually works. And great, we see we have a super fast algorithm. We're not using any extra space. And that just about wraps up another question on the Blind 75 list of LeetCode questions. If you're enjoying the series, please like this video and hit that subscribe button, and I'll see you again for another question.